The power grids of the world are the life support system of modern society. The grid has empowered human beings beyond the wildest dreams of our predecessors. It affords us many of the creature comforts that simplify our existence. The magnitude and interlocking complexity of these systems is beyond the grasp of most people, who simply fail to perceive all of its vulnerabilities because it's all they've known their entire lives. However, the phrase, "the bigger they are, the harder they fall," is a phrase that best describes the fragility of the modern power grids of the world. In today's video, we are going to talk about one of the major threats that could cripple this system in an instant and have a cascading impact that would threaten the sanctity of civilization as we know it. That threat is that of electromagnetic pulse caused by geomagnetic storms or a high-altitude nuclear detonation. So let's get to it. This video is in part sponsored by the Energy Kodiak Power Generator Company. The Kodiak Power Generator is the world's most advanced portable lithium-ion power supply, with over 1 kilowatts of power in a 20-pound package and a peak output of 3,000 watts with 1,500 watts continuous. It can be charged in only 3 hours with a 600-watt input via solar power. And with nearly 2,000 recharge cycles, it's sure to be with you through the worst of a long-term grid down scenario. Use coupon code Canadian Prepper for 20% off this amazing power generator. Now let's get to the video. The human race faces many existential threats: superbugs, ecological disaster, global conflict, and economic collapse. However, one of the greatest risks to civilization isn't known about and is much less understood by the overwhelming majority of people. Now, an electromagnetic pulse is a burst of electromagnetic energy that can potentially destroy any electronics within the line of sight of the blast. An EMP can be caused by a nuclear detonation, particularly a high-altitude one, geomagnetic storms caused by solar flares, or modern electromagnetic pulse weapons. Now, an EMP has the potential to render electronics in the power grid useless, possibly irreparable, which would incapacitate many essential infrastructures in society. This would cascade rapidly to the breakdown of society, leading to desperation and lawlessness. The purpose of this video will be to provide a comprehensive review of the most up-to-date research on EMP. We're going to examine the likelihood and scope of these threats, as well as an in-depth breakdown of how it might impact the functioning of society. We'll also look at what's being done by the authorities to prepare for it, and what you yourself can do to prepare for these events. So before we really delve into the intricacies of EMP, it's important to understand the grid as a patchwork of interdependent infrastructures that collectively perform the vital functions of a society. So it's comprised of everything from computers, telephone lines, power lines, transformers, appliances, and essentially anything which is powered by electricity. And the grid becomes more dynamically interwoven into our way of life as technology continues to evolve. And as a result of this, we become more reliant and dependent on it for our survival. As this technology evolves, it affords us more luxury. It affords us greater efficiency, and increasingly it fosters faster communication, enabling greater information sharing at increasingly faster rates. So this is why it's very hard for people to imagine that these advancements make us more vulnerable as a society. Because technology is so ubiquitous, we wonder how it ever could just go away. What's worse is that as we become more reliant on technology, many of our traditional skills and our natural abilities are going to go unused, and of course those things and capabilities are going to go extinct. They're going to atrophy. In order to adapt to the current society, we need to forego our traditional and primitive skill sets, and we come to rely on new skills that grow out of the technology that we're utilizing. But the grid is very much like a small microchip. If the right part of that grid is compromised, then there's the potential for the entire system to fail. For example, one blown fuse is all it takes to make a vehicle not run, and our power grid isn't much different than that. The only reason why the urban jungles even exist is because technology to deliver resources from far away, pump water from downhill, and provide electricity from power plants that is thousands of miles away, our ability to remove and treat waste and provide heat to homes via pipelines which span thousands of miles across the continent, and of course provide law and order to maintain this orchestra of activity, and a whole host of other factors are what make the modern metropolis possible. Most of these cities are reliant on just-in-time delivery systems in order to meet their demands. So in order to achieve maximum economic viability within any society, we are necessarily 9 meals away from anarchy. One thing is for certain, that if the food trucks were to stop rolling today, it wouldn't be long before the hunger took hold and the metropolises of the world would quickly devolve into post-apocalyptic battle arenas. We need to understand, and increasingly more so, that our grid was built for high efficiency. It was not built to be secure against the threats that we're going to outline today, like EMP. And there are many challenges, as we're going to find throughout this discussion, as to why it's not as easy as people would think to secure against EMP. There's the technological hurdles, but there's also economic ones and very dynamic ones. Obviously, the costs of creating a power grid which was resilient and redundant is much less so than the cost of the consequences. It's a matter of billions of dollars compared to trillions of dollars if we were to do nothing, and potentially we may never recover from that. And we're going to talk about the reasons why. But let's first talk about the different types of EMPs there are. So the commonly talked about form of EMP is the result of a nuclear bomb. Now, any nuclear bomb has an electromagnetic impact. However, there are certain bombs nowadays, and that are probably top secret and unbeknownst to the public, which are designed to be EMP enhanced nuclear devices. So like I said, a lot of this information is top secret, but it's safe to presume that there are devices that are engineered in secret that are going to try to maximize this effect. And this sort of clandestine operation would be no different than the atomic bomb being created by the Manhattan Project. Now, there's obvious reasons why this would be a strategic move from a militaristic standpoint. Some people have argued that it would minimize the necessary damage that would need to be done in a mutually assured destruction scenario if Russia and China and the United States started lobbing nukes at each other. If they were to first launch high-altitude nukes, which would dismantle the power grids of the affected countries, that would not only limit the receiving country's ability to respond and defend themselves, but it will also minimize the amount of megaton yield that would need to be dropped on these countries to pacify them and neutralize them. It would be foolish to presume, just like we are unaware of where all the secret bunkers are, that there were not fairly significant advances already made along the lines of electromagnetic pulse that we are simply unaware of, and that only the military is aware of. But it is worth knowing that the military has most of their equipment made to be EMP ready. I think to any thinking person that should be evidence enough that EMP is a legitimate threat and not just some conspiratorial fantasy. Even since the effect of EMP has been known, many countries who utilize nuclear technology have tried to harden their infrastructure in a way to mitigate this threat. So for example, during the Cold War, Russian planes used vacuum tube electronics. Vacuum tube electronics are not as sensitive to EMP as solid state electronics, and thus they could potentially survive an EMP blast. So measures like that have been taken by countries to offset the damage. It's important to note, however, that although vacuum tube electronics are more resistant to EMP, generally speaking, the much more evolved transistors that replaced vacuum tube electronics are far more durable and long-lasting, with the exception that they are vulnerable to electromagnetic pulse. Although the concept of using vacuum tubes in place of transistors has been quite romanticized, the fact is, is that these vacuum tubes require frequent replacement as the filaments within them burn out just like light bulbs, and they are drastically more primitive in the technologies that they deliver. So an EMP attack then, a high altitude one, the idea is that it's going to seriously degrade, or it's going to potentially totally shut down a large part of the electric power grid in a geographical area of EMP exposure. Now there is also the possibility of functional collapse of the grid beyond the actual exposed area, and this is because there's a potential for that electricity to have a cascading effect throughout the grid, meaning that because the grid is totally interconnected, this electromagnetic pulse could travel through the grid itself from key nodal points within the grid. Now it's been said that there are 9 key nodal transformers within the United States, which if precisely hit with an EMP could permeate through the entire grid and trigger a chain reaction that could basically down the entire US power grid. Now I don't have the specific information with respect to which 9 key nodal transformers those are, but that has been something that has been brought up by an organization called the EMP Commission, which I will talk about in greater detail later on. So an electromagnetic pulse is an intense burst of electromagnetic radiation that is going to couple into the circuitry of the power grid at large and even smaller scale electronics. This is going to potentially cause damage within these systems, which in some cases would be very destructive and permanent. Now the effect of EMP caused by nuclear detonation is going to be magnified commensurate to the height or the altitude that the bomb is detonated. This is because, as previously mentioned, the impacts of EMP are felt by anything within its line of sight, meaning the higher up the blast occurs, the larger the diameter of Earth is going to be impacted by the flood of electrons and ionized particles exalted by the blast. So it bears repeating that a lot of what we know about EMP is necessarily classified information. So this makes it very hard to investigate what the impacts are going to be. And there's a lot of other players involved. There's people who are trying to profit from EMP hardening, and there's people who are trying to resist government mandating of having to harden their grids, because the patchwork of the US power grid is comprised of thousands of different companies, private companies, which of course would have to bear some of the bill to put this all together. So there are some special interest groups which are trying to minimize the threat of EMP, and other SI groups that are trying to maximize EMP. So basically what scientists have been relying on then are simulations, documented historical records of past EMP effects, like past detonations, and of course scientific theory in order to predict what the impacts are going to be. So the ideal altitude to trip a nuke in order to generate the most devastating EMP impacts is going to be anywhere between 100 and 500 kilometers. Remember, the higher up it is, the longer the line of sight. But the pulse strength is going to diminish as the wave gets further and further away from the blast. So indeed, the most severe impacts are going to be felt within a few hundred miles, and that's going to gradually diminish as those energy bursts push farther across the continent. Now there's actually 3 general pulses that are emitted by a high altitude nuclear weapon, and they're referred to as E1, E2, and E3. And all of these effects are going to be felt in the case of a detonation of a high altitude nuclear weapon. So the E1 portion of EMP, it's a short but high frequency pulse. So this is going to be very fast, less than a second. It's going to be brief, it's going to be intense. Now this pulse is potentially going to do damage to smaller scale electronics, because every semiconductor chip has a breakdown voltage which is going to be potentially exceeded by this E1 pulse. And this is going to be destroying computers, comms equipment, any small electronic which is not protected by some sort of Faraday cage, be it man-made or natural, has a potential to be fried by this E1 pulse, which can have a peak amplitude of around 50 kilovolts per meter. Now there's also an E2 intermediate pulse, and this one has similarities to the electromagnetic pulse which is produced by lightning, and it's not the most critical of the 3, but it may actually have compounding impacts, as this is going to happen immediately after the E1. So the E1 happens in less than a second. The intermediate pulse, or the E2, is going to happen within 1 second, so right after the E2. So it's those compounding cumulative impacts of having the E2 follow the E1 which may do some damage. But the E2 itself doesn't have a significant impact on small-scale electronics because its peak amplitude is only 0.1 kilovolts per meter. Now, the most damaging of all is the E3 pulse. And this one, you're not only going to find in a high-altitude nuke detonation, but you're also going to find it in geomagnetic storms. And this long portion of the EMP pulse is a super energetic radio wave. And it's going to last tens of seconds. It can potentially last a minute, forcing electrons at very high voltages into the grid. It's going to couple with the long power lines, the long transmission lines, which is going to potentially cause serious damage to the larger transformers within any given country. But for this example, of course, we're talking about North America, so the United States and Canada. So what they do know about nuclear weapons and EMP yield is that you don't actually need a large yield nuke in order to generate a large EMP. So I'm going to read you an excerpt here which explains this in relatively simple terms. So you don't need a large nuclear bomb to generate a large EMP. In fact, the gamma yield enhanced nuclear weapons are engineered to generate a large amount of EM power and less nuclear blast than standard designs. Essentially, you have high gamma ray output with low megaton yields. Physicists have testified at United States congressional hearings that weapons with yields of less than 10 kilotons or less can actually produce large EMPs of this sort. This means that a rogue nation or group would only need access to small amounts of nuclear material and a warhead capable of launching it into space. It should also be known that EMP could be potentially triggered by a missile defense system. If a missile defense system intercepted a ICBM at very high altitudes, and for some reason that warhead was designed to go off if it was hit, then that could potentially be disastrous. Now, there's a more in-depth explanation of how this works, but I'm going to put that in the comments section, and you can analyze that further for yourself. But essentially what they're saying is you don't need a large nuke necessarily to generate a fairly significant EMP. In fact, it can be counterproductive. But it should also be known that this lack of impact of the size of the nuke only pertains to the E1 and to the E2 portion of the pulse. The E3 version of the pulse, which is probably the most significant in terms of preserving the power grid as a whole, well, in that case, the bigger the bomb, the bigger the damage is going to be. But the bigger the bomb, not necessarily the bigger E1 and E2 pulses. Now, what we're looking at here is a smile diagram, and it shows you the energy peak as it's radiating away from the blast area. So it's important to understand how the EMP is going to actually affect the power grid. Everybody always says, well, the EMP is going to take down the power grid, but not many people understand the intricacies of how that happens. So that's what we're going to talk about now. And it's important for you to have a good conceptualization of what the power grid is. Basically, an electrical grid is a way of delivering electricity from producers to consumers. And it's comprised of three main components. Now, the first component, of course, is power generators. You need power to be generated somehow. And usually, in Canada in particular, these are going to be mechanical, so things such as hydro, wind, or wave. In most cases, it's also going to be chemical, so they're going to use fuels like petroleum, coal, natural gas. It could be thermal, geothermal, solar, or of course, nuclear. Now, unbeknownst to most people, in the United States, about 75% of the country's power generation is based on chemicals. So they're relying on things like coal and natural gas. Now, some coal plants do have fairly large stores of coal on site or near site, so they would potentially be able to keep going in the case of an EMP disaster. But other ones which rely on a more just-in-time delivery system, which run, say, on natural gas, well, those ones are going to have a much harder time, and they're not going to have as many supplies on hand. They're going to rely on the transport system, as we're going to talk about, is potentially going to be compromised in the case of an EMP. Now, the only real threat to the power generation system in the case of a high altitude nuke is going to be in the actual frying of the electronics that help the power station run. Most power stations themselves actually have a fairly significant degree of protection against EMP. But like in any modern facility, there's going to be a variety of conductors and actuators which take that electricity and move it into something physical. That's what's at risk with EMP, at least the first part. Now, probably the most vulnerable are going to be the transmission lines. And of course, the transmission lines are the lines that carry the very high voltage energy from the power generation station over very long distances. This is achieved through a series of transformers and larger substations and billions of miles of power lines. Now, this transmission system is probably at the greatest risk of susceptibility to the E3 part of the pulse. Remember, the E3 part of EMP are the larger radio waves that are going to couple into the longer receivers, like those power lines. Now, the third thing that comprises the power grid is the distribution system. So the transmission system is often stepping power up. That's taking that power, say from a hydroelectric plant in the northern reaches of Canada, all the way down into the Great Lakes. That power is transmitted, and then it's distributed, and it's actually step down and step down transformers and substations into lower voltages, which then can be distributed to the end user. And this is where 90% of the power outages, when you have a power outage during a storm, this is where it's caused. It's caused at the level of distribution, in that a tree is going to fall on a power line, and that power is not going to reach a certain neighborhood. Very seldom do those storms affect things on the transmission level, because if they did, you would have citywide blackouts quite often. So our power grid is actually relatively new. It's only been around since the 50s, since post-World War II era, and it has integrated a lot more microelectronics, which means we are much more vulnerable to the effect of EMP as time goes on. So the electrical system requires an almost flawless functioning of this patchwork of semiconductors and actuators that go into regulating that system. And it's important to understand that the transformer is the most critical link in this network, because the transformer is what links the generator to the transmission lines. You're going to find them throughout the transmission network to either step up or step down the amount of power. You're going to find them in between transmission and distribution systems, and you're even going to find them between distribution systems and the end user. So transformers are the key. And most of these transformers, the significant ones, the nodal ones that I talked about earlier, these are large, they're very expensive, and in most cases they need to be custom built. And almost 99.9% of these transformers are made offshore in either China or India. Now, currently, in the best of times, they say that it's going to take at least 2 to 3 years for a transformer to be built, custom built, and sent to the United States. And of course, there are around 2,000 of these large ones in the United States that function over 345 kilovolts. So just imagine if even a couple hundred of those went down in key nodal areas, how hard it would be for the rest of the world to fulfill that demand. And this is all contingent on a stable global geopolitical landscape to foster the delivery of these transformers. So it's presuming that all of these other countries are going to have it good enough that they're still able to help us out with our problems. So it's important to understand that in historical power outages, often these things are regional. At best, they're probably on a neighborhood by neighborhood basis, maybe on a county by county basis. But by and large, they're quite isolated incidents. And more often than not, these situations can be resolved with external help. In addition to that, in most of those cases, you're having functioning telecommunications. You still have ample fuel supplies to power the transport system. But in the case of a geostorm or a widespread EMP, it's safe to say that the system would easily be overwhelmed in its capacity to restore power within a reasonable frame of time. If even 25% of the country were to be seriously impacted by power outages, that would put significant strain on the federal government's ability to respond and coordinate aid to those areas. And that in itself could potentially have a cascading effect, which would lead to economic collapse and the potential for ecological collapse, and all of these other things which are interwoven with these interdependent infrastructures. So for instance, there's numerous factors that make EMP such a high impact event, even though it's low probability. Think about the lack of telecommunications. So if you needed a skilled labor to perform a certain task, say you needed them to repair some aspect of the grid, well, how would you get that person and coordinate them to go to the right places without telecommunications? And this is all contingent on that person's skill level, whether or not they have the tools, whether or not they have the replacement parts, whether or not there's law and order in place in that particular region to foster the reconstruction of those transformers, and even just ensuring that that worker has food and has eaten that day so they actually can do the job properly. It would be much more challenging to coordinate a relief effort in the case of a nationwide blackout. It would almost be impossible, and we really would have to rely on more primitive means of communication, possibly radio communication, to coordinate all these things, back like we used to be able to do when there was only 3 billion people on the planet. So some people say that it's impractical to try to protect the grid from EMP fully because there's so many different components and different types of manufacturers and designs that they would have to retrofit, that it would take years and years, and you'd never be able to fully harden it with 100% certainty. Now, I'm not going to go into the details of that, but some people argue that the transformers cannot actually be hardened, whereas others seem quite confident that they can. Generally speaking, people do seem to be optimistic that if the money was there, that the grid could be hardened against the worst effects of EMP. So the real goal here then is to minimize the impact of the event. The strategy would be to have some grid hardening, have some spare parts on hand, and more backup power generation on site, separating different interconnected systems wherever possible, and basically focusing on recovery and restoration as opposed to totally preventing it. So in the next part of this series, we're going to look at the different areas of critical infrastructure which are identified by the Department of Homeland Security, and we're going to walk through how each of those different sectors would be impacted by an EMP. So we're going to talk about energy, how water and wastewater treatment is going to be impacted, information tech, healthcare, agriculture, government functioning, emergency services, financial services. All of these sectors are going to be discussed in detail in terms of how they are impacted by EMP in the next video. So stay tuned for that. Don't forget to like, comment, subscribe. Thanks for watching. Canadian Prepper out. This video was in part sponsored by the iNergy Kodiak Power Generator Company. The Kodiak Power Generator is the world's most advanced portable lithium-ion power supply. With over 1 kilowatts of power in a 20-pound package and a peak output of 3,000 watts with 1,500 watts continuous, it can be charged in only 3 hours with a 600-watt input via solar power. And with nearly 2,000 recharge cycles, it's sure to be with you through the worst of a long-term grid down scenario. Use coupon code Canadian Prepper for 20% off this amazing power generator.